I'm going to start the recording of this. You'll get, tomorrow morning I will send you a link to how to watch the recording of this. And it's always the same place that you go. My Digital Math Tutor YouTube channel. All right, so this looks like, this is just one chapter, chapter 10, individual test review.
Yeah.
All right. Gosh, I was looking at this material and it looked like a whole semester's worth of material.
And I think I sent you both the review and actually the key that the teacher puts out.
The key is all of the writing below each problem. I presume that he didn't write all of this.
No, he did not.
No,
So
otherwise you wouldn't be in need of a tutor if he wrote all of that.
Exactly.
Oh, okay. Well, at least my deductive skills are okay. All right. Well, Nicholas, let's see. The key actually complicates things a little bit just because it's hard to look at the problem without looking at the key and the solution. And so it takes away a key process in the learning, which is figuring out how to do the problem.
Okay.
Do you have any way of looking at these without the answer staring you in the face? Let's see. Yes and no. In other words, the only way I can look at it is to look at what you've sent me here. Let's talk about arithmetic and geometric sequences, first of all.
Okay.
What is the general formula for the nth term? I also noticed that it looks like you use terminology here that's a little different. Doesn't make any difference to the answers, but the terminology that I'm used to is the nth term being a sub n. So what's the general formula for a sub n?
Just like what?
Well, when I say the general formula, I mean it's always equal to the first term, a sub 1, okay, plus the common difference times n minus 1. That's what I mean by the general formula. In other words, this works for any arithmetic sequence, okay?
Yeah.
Including the one we're looking at here. You can look at that sequence. What's the first term?
-5.
What's the common difference?
-6.
And if you plug that in, you'll get a sub n equals -5 plus a -6 times n minus 1. And now this allows you to calculate any term you want. If they want to know the 17th, or in this case the 15th term in the sequence, which she's calling t of 15, I would call that a sub 15. Equals -5 minus 6 times 15 minus 1.
Yeah.
All right. What is the general formula for the sum of the first n terms of a sequence?
It's the number of terms divided by 2, and then times the first term plus last.
Okay. And when she asks for the sum here of the first 15 terms, that's what we put in. 15 divided by 2 minus 5 the first term. The last term, which was the 15th term. In other words, we needed to do both parts of this problem. we needed to figure out what the 15th term was in order to figure out the sum, because the sum requires you to have the nth term. So we had to figure out the 15th term using the a sub n formula, and then we could figure out the sum using the sum formula. Now, as long as I got it on my page here, what's the general formula for a geometric series?
It's first term, and then in parentheses the multiplier, and then to the power of n minus 1.
Okay. Are you comfortable with this terminology, a sub n, as opposed to t of n? Is that what your teacher is writing here?
Yeah, t of n, and then
t of n. Interesting. I've never seen arithmetic sequences or geometric sequences represented that way. Even though I understand it, it actually makes a little more sense. It's a function of n. And yeah, it doesn't look like Greek to most students, because I think a lot of students have difficulty with arithmetic and geometric sequences just because of the terminology is new. This subscript terminology. So teaching it this way, I kind of like.
Yeah, it makes more sense.
Yeah, it does seem to make more sense. And what is the general formula for the sum of a geometric sequence?
First term, and then times the multiplier to the power of how many terms there are.
Actually, it's 1 minus r to the n divided by 1 minus r.
Well, she also taught us how it can go the other way from like the Rn minus 1
yeah, I
over.
noticed that in reviewing this, and she's correct. It can also be written r to the nth minus 1 all over r minus 1. Let's just talk about that for a second, why that's true. First of all, a minus b is always equal to the negative of b minus a. For example, 3 minus x is equal to the negative of x minus 3. Okay? So if I have 1 minus r to the nth, that's going to equal the negative of r to the nth minus 1. And the denominator, which was 1 minus r, is going to be the negative of r minus 1 also. So when I divide that by that, I could just as easily divide that by that, and the negatives cancel. And so it could be this. Now, I'm not sure why you would ever want to make it this way, is the thing. Because r is almost always a number that's less than 1.
True.
And if r is a number less than 1, then when you take it to some n power, it still is less than 1. And so you'd want to be subtracting that from 1. You wouldn't want to be subtracting 1 from that small number, because you're just going to produce negative signs. In other words, what I'm saying is that that's true. Okay, well, over here where I'm pointing, in case you can't see. This is certainly true, but I can't really think of why I would ever want to do it, because if r is a number less than 1, you would want to do it the manner on the left. This gives you positive numerator and a positive denominator. Whereas if I did it over here, I would end up with a negative numerator and a negative denominator, and the negatives cancel, but I still don't know why you would want to do it that way. But anyway, it's useful to know that a minus b is equal to the negative of b minus a. That comes up more than once.
Okay.
All right, let's see. Guess we just probably should go through each of these problems, and I don't even have a good way of covering them up. Or do I? Maybe I do. Yeah.
You should have a clean copy and then the key copy.
Do I have both copies?
Yeah, you should. I emailed them both.
Ah, that's the other document. Ah, I'm used to getting 2 documents for 1 paper. That's the way to do it then, for sure. Yeah. Oh, good. All right. Hold on a second. Let me get it arranged on my screen the way I want. Yeah, it's hard to tutor when you're staring at the answers. It just makes it different. All right, so let's look at number 2. Let's see. The total question says, can you read it on my screen here, or do you want me to blow that up a little bit?
I can read it.
You can read it? Okay. So it wants to find the sequence and the sum. And when it says you can use a calculator, that helps you add the numbers and multiply them, but that's all. In other words, you can't, she doesn't want you to go in the calculator and find the arithmetic sum, if you know what I'm saying.
Yeah.
Okay. So first of all, let's look at number B. Is that a geometric sequence or an arithmetic sequence?
Geometric.
Okay. So what's the general formula?
Do you want like the numbers in it or no numbers?
No, not yet. You know what? I think you should always, until you get really, really comfortable, you should always start out every problem with the general formula. I really believe in that strongly. And it pretty much, no matter what subject I'm tutoring, whether it's algebra, geometry, trig, if you start out with the general formula and write it, then it's just a question of filling stuff in. So what's the general formula for this one?
It equals first term times multiplier to the power of n minus 1.
All right. And what the way I would verbalize that would be a sub 1, the first term, times the common ratio, which is the common multiplier, to the n minus 1. All right,
Okay.
so let's figure out what a sub 15 is. Fill in everything you know.
So it equals 88 times 0.5 to the power of 15 minus 1.
Yeah, hold on a minute. I guess I got ahead of myself there a little bit. Let's figure out what the nth term. In other words, this is the general formula for an a geometric sequence, but she wants the specific formula for the sequence. Okay? Well, the specific formula, it's got the first term, 88, and it's got the common ratio, which is 1/2, to the n minus 1. So that would be the first answer for this problem.
Yeah.
Hold on 1 second here. Needed to shut my office door. And in terms of S sub n, what is it?
It's first term, and then in parentheses the Or wait, do you want the...
Do it in whatever order you're comfortable with.
Okay.
Do it either 1 minus r or r minus 1.
Okay. And then 0.5 to the nth minus...
Hold on. Let's come up with the general first. In other words, it's 1 minus 0.5 to the n divided by 1 minus 0.5, right?
Yeah.
In other words, if I use this as specific, now I have the specific equation of the sequence, and I have the specific equation of the sum of any n, the first n terms. And so is all I need to do is plug in 15 here. So S sub 15 equals 88 times 1 minus 0.5 to the 15th power all over 1 minus 0.5. You see why it makes a little more sense to do 1 minus instead of r to the nth minus 1? I can't really imagine why she would do it that way, because when r is always less than 1, and when you take it to a power, it just gets smaller. So if I want a positive numerator and a positive denominator, I'm going to do it 1 minus r to the nth.
Okay, makes sense.
I don't think we need to spend our time figuring out these answers.
Yeah.
Especially since you have a key that will show you the exact answers. It does not serve us any purpose whatsoever to just have you go into your calculator, unless you don't know how to do it. Do you know how to take 0.5 to the 15th power?
Yeah.
Okay, as long as you know how to come up with this number, that's what's important.
Okay.
All right?
Yeah.
Let's go to the next problem. What kind of sequence is this?
Which number?
Number C.
Number C? Arithmetic.
Okay. So again, tell me, we'll just keep repeating it. So what is the general equation?
First term, a sub 1, and then plus the multiplier, and then times n minus 1.
Yeah, notice with arithmetic sequences, you're always adding, not multiplying. And the n minus 1 is on the algebra line. It's not an exponent. So, okay, and fill in everything to give me the specific equation of this sequence.
Okay, so it equals 2 plus 3, and then n minus 1.
Yeah, now, whether or not you need to simplify this or not, I would say yes, you probably do. If she wants the specific and you gave her that, you might lose points, because I can simplify it. In other words, I can multiply that, I can distribute the 3, and now I can combine the numbers. So I end up with minus 1 plus 3n. That's really the nth term. Okay, this is the answer you'd want to get.
Okay.
Okay. And now I need the sum of the first 15 terms, which, what's that specific formula going to be for an arithmetic sequence?
Number of terms divided by 2.
Which is 15 over 2.
And then the first term plus the last term.
So it's 2 plus a sub n, but we don't know what a sub n is. We've got to figure it out. So let's go back to the previous line and figure out what a sub 15 is. What's that end up being?
44.
Okay. Now we can substitute that, 44 for that. And again, now it's just arithmetic. All right, let's look at number 2. Find the sum of this sequence. Well, is it arithmetic or geometric?
Arithmetic.
Okay. So we know that in order to find the sum, and that's all they want, what's our general for the sum of an arithmetic?
Number of terms divided by 2, and then first or times first term plus last.
All right, and the tricky part on this is that we need to figure out which term that is. Because if I'm going to sum up all of the numbers that go with this sequence, I know what a sub 1 is, but I don't know how many terms there are. So the first thing I got to do is solve. Well, I know that the general is 1 plus 10 times n minus 1. And so if I let the nth term be 161, in other words, I don't know what it is, but I can tell that it's 161, I'm going to make that the nth term, and I'll be able to solve for n. And solving this algebraic equation, you get 160 equals 10 times n minus 1. So n minus 1 equals 16, n equals 17. So there are 17 terms. Now that I know that 161 is the 17th term. You with me?
Yeah.
Okay. So now I know everything that I need to know. In other words, the missing thing here was the number of terms. Well, now I know it's this. That's 17. First term is 1. I know the nth term is 161. Again, it's just arithmetic now.
Yeah. Okay.
All right. Part B. Is that arithmetic or geometric?
Arithmetic.
So we're going to do part B virtually identical to the way we did part A, right?
Yeah.
All right, so work me through it.
So,
Give me the specific for this sequence. Not the general. I know you know the general. What's specific?
-7 plus 6, and then n minus 1.
Okay. Now, what's the next step?
To find how many terms.
Well, give me what S sub n is going to be.
Okay, it's n over 2, and then -7 plus 299, or first term plus last.
Yep. But notice that I need n to answer what S sub n is. So I need to figure out which term this 299 is. How do I do that?
You plug in 299 into the first equation.
That's what the nth term is going to be, and I'm about to figure out what n is. In other words, now it's just algebra. Go ahead and help me solve that equation.
So 306 equals, or I guess,
yeah, I'm going to have 306 divided by 6 equals n minus 1, right?
Yeah.
Well, 6 goes into that 51 times, so n is equal to 52. So now what I'm really looking for is S sub 52. Now, there you go. Now it's all numbers, no more unknown variables. Now I'm curious, I guess I could look at the key, but I don't want to bring it up here particularly. When she's doing sums, does she do it this way or does she do it S of 52?
She does it that way.
This way or the other way?
Yeah.
No, she does it. She uses a subscript.
She just uses T of n equals the 52 over 2. And
or S of n, huh? In other words, she uses it like function notation, the whole for both the sequence equation and the sum.
Well,
let me look at her key real quick. Easier said than done. No, I don't need to look at her key. I just don't want to confuse you by using terminology you're not used to. You okay with my terminology so far?
Yeah, I'm good.
You're understanding it even though I'm using subscripts?
Yeah.
All right. 2C. Arithmetic or geometric?
Geometric.
Okay. Now, to find what's the general formula for the sum of a geometric, and I'm going to write it down here because I need to know what I need to know.
It's the first term.
A sub 1. Okay.
In parentheses, the multiplier.
Well,
the number of
1 minus r.
Yeah, well, I'm doing
or
it
r
way.
minus 1, but it's not just the multiplier. In other words, you can write this either way. R to the nth minus 1 or r minus 1, as long as you do it both that way.
Yeah.
But it's not just the multiplier. The multiplier is just r. Okay? So to figure out this sum, again, I have an end term, but I don't know which term it is. In other words, I need to know, I know what r is. What's r?
1/5.
Okay. And I know what a sub 1 is. That's 500. So the only missing thing is n. So we've got to figure out n. Well, let's go up here and give me the specific equation for this, for a geometric.
Mm.
You can give me the specific. You don't have to start with the general.
Okay, so 500 times 0.22 the n minus 1.
And now they're telling us that some nth term is equal to 0.00000512. So now I got to solve for n. Here, I'm going to give myself a little bit of room here. And this solution's a little more difficult. Whenever your variable is in the exponent, you need to use logarithm to solve for it. Okay?
Okay.
And in order to solve for n here, I've got to isolate that part of it first before I take the logs of both sides. So what's my next step?
Divide 0.000 512 divided or by 500.
Okay, so I'm going to get rid of the 500 over there and put it over there. Now what's the next step?
Take the log of both sides.
What kind of log?
I'm not sure because when I did it, I just did a guessing check and kind of just went
You
down.
can use any log you want. The one I always use when I'm dealing with numbers like any of them is natural log. Natural log is the log of calculus, first of all. So once you start taking calculus, you won't work with very many logs other than natural log. So when you've been through calculus, you'll end up always using natural log to solve these kind of equations. I could also do common log. I could also do log base 0.2. But all of those ratios end up being the same. In other words, let's just talk about that for a second. The natural log of 7 divided by, this is just totally made up numbers. These ratios are exactly the same. I could say log base 17 of 7 divided by log base 17 of 2. In other words, that ratio is the same as that ratio is the same as that ratio. And because that's true, that's why it's not going to matter what log we use. The nice thing about common log and natural log is you have a key on your calculator for those. You have a TI-84 or an Inspire?
TI-84.
Okay, with the TI-84 you only have a common log key and a natural log key. So it's harder to work in different bases. Do you know how to, if somebody gave you this answer, do you know how to figure that out on your calculator?
No.
Use the change of base formula. So that becomes the log of the higher number divided by the log of the base. And then you've got, that's common log, or natural log of 7 divided by natural log of 17. So the fact is that when you're dealing with these oddball bases, you've got to use this change of base formula to come up with an answer. Therefore, it's better not to deal with those oddball bases. You want to generally either use common log or natural log. So
Okay.
I've used natural log here. Now, once I do this, why did I do it? What does it allow me to do?
Find
Once I got it in log form, I can take that exponent and using the rules of exponents, put it right in front like that. Okay, so that gives me n minus 1 times natural log of 0.2 equals what I had on the left side, which was natural log of 0.000512, but yeah, all over 500. Okay. Now, the important thing to understand about logs is they're just numbers. Okay, this thing is just a number. So if I want to solve for n, I'm going to treat this like it was a coefficient in front, and I'm just going to divide both sides by it. So I'm going to divide both sides by natural log of 0.2. And that gets it rid of from there. Now to solve for n, I add 1 to both sides. So plus 1 is equal to my n. Now, another decent thing to know is that when you take the logs of numbers greater than 1, you get positive answers. When you take the logs of numbers between 0 and 1, you get negative numbers. So this numerator is going to be negative, but so is the denominator. And so I should end up with a positive number, and we better. If you end up with a negative n, you're in trouble. You've made a mistake, because n cannot be negative in this case. N is an integer from 1 to infinity.
Yeah.
All right? But I feel safe here because I know that that's a negative number and that's a negative number. So a negative divided by a negative is going to be positive, and I'm going to add it to 1. So n will be positive for sure.
Okay.
All right, let's go on. Hold on. I'm going to get my picture back. All right. So again, we didn't do the math, but we can solve for n, and then once you have n, then you can do the sum of n terms.
Okay.
All right, let's look at D. D is kind of the same kind of problems as A, B, and C. The only difference is they give it to you in sigma notation, but they also tell you what the nth term is. Well, they give you the formula. In other words, essentially what they've given you here is A sub n. It's equal to 50 minus 4n. And that's going to allow me to figure out all the terms.
Uh-huh.
What's the first term?
50.
Plug in n equals 1.
44.
46.
46, yeah.
Okay. That's the first term. What's the second term?
42.
Third term?
38.
So this is an arithmetic sequence. That's first of all. That's why I listed the first 3 terms, so that we could tell whether it was geometric or arithmetic. And arithmetic sequences look like this, whereas geometric sequences look like E and F.
Okay.
Okay. Yeah, okay. E, we have an R that's greater than 1. So when we do E, we can do R minus 1. I can see now why she would choose to do that if you have an R greater than 1. Incidentally, if you're looking, have you guys talked about infinite series yet, where n goes from 1 to infinity?
No.
Well, if you're talking infinite series, R is always less than 1, always. Because if R is greater than 1 and you have an infinite series, then the sum is infinity, and there's no point in even talking about the series. So for an infinite series to be even worthy of discussion, it has to have an R less than 1, and that's why I prefer to use 1 minus R rather than R minus 1.
Okay.
All right, let's go back to D. So D, we need, what's the sum going to be? What's S sub n of an arithmetic series going to be?
The number of terms divided by 2, and then first term plus last.
All right, how many terms are in this series for D?
22.
Okay, so we're going to need A sub 22. What's that going to be equal to? Let's do the math here, just because we need it to go to the next step.
Negative 38.
Okay. So now, tell me everything else I need. S sub what equals what?
So S of 22 equals 22 over 2. And then times 46 plus negative 38.
Yeah. Now you can do the arithmetic on your own. Let's get these set up. All right, so E, already talked about it. It's a geometric series. And that's because the variable, for one thing, it's in the exponent, and it looks just like our geometric series look. How many terms are in this one?
11.
Okay, so I'm going to want S sub 11. What's it equal to? A sub 1 times what? And this time we'll do it your way. R to the nth minus 1 all over R minus 1. And I'm going to do it this way because in this case our R is a number bigger than 1. However, I still need the first term. What's the first term? How do I get the first term?
Plug in 1.
Into that. And if you plug in 1, we got 3 to the 0th. Any number to the 0th is 1. So 5. A sub 1 equals 5. What's the common ratio going to be?
Times 3.
Common R is going to be 3. Right. Okay. And that's everything we're going to need, is it not? I think so. S sub 11 equals 5 times 3 to the 11th power minus 1 divided by 3 minus 1. Again, I will leave the arithmetic up to you. Or your key. I guess you don't have to do the arithmetic if you got that key, huh?
Yeah.
I don't know if that's a good thing or a bad thing. In general, I'm kind of a fan of giving a key, although I kind of prefer it being in the back of the book, like most books will have all the odd answers in the back.
Yeah.
I really believe that it's helpful being able to look up an answer just when you do a problem. If you know or can look up your answer, you know that you did it correctly. As opposed to not having a key, then there's always that lingering doubt as, did I do it correctly? So I like having the answer key, but I really hate having it staring you in the face when you're trying to do the problem. To me, that is self-defeating. You might as well just be reading an example problem. You know, all of these type problems, usually there's an example problem. And those example problems are extremely useful to figure out how to do the problem. If you can't figure out how to do a problem, the best way to try to figure it out is to try to find an example similar to it. Follow that logic, and then you generally can apply the logic to whatever problem it is that you're trying to figure out. All right, let's look at F. F's a little different looking. First of all, how many terms are there in F?
7.
Count them. 0 is the first, right? And then 1, 2, 3, 4, 5, 6, 7. That's 8 terms.
Okay.
So the way you always really figure out how many terms is to take your top number, subtract the bottom number, and add 1. Notice that in D, if you take 22 minus 1, you get 21, but you have to add 1. That makes 22 terms. Same thing as
Okay.
E. 11 minus 1 is 10. Add 1, you get 11 terms. Well, F is unusual in that N is not starting at 1. It's starting at 0.
True.
And that's fine. N can start wherever you want it to start. You could have N start at 5. You could have it start anywhere you want as long as the function makes sense. Okay? So I'm really trying to figure out S sub 8. What are the sum of the first 8 terms? What's the specific again?
The specific.
Well, give me the first term.
Okay. It's.
Yeah, let's go
4.
back and figure out the first term, because we know we need the first term, right?
Yeah.
So what do you get when you plug in 0 for N?
4.
Okay, so that's the first term. So we've got N being 4 times, what's the rest of it?
It's for geometric. It's the 1 minus r to the n.
So let's fill in the specifics. It's 1 minus 2/3. That's r. I forgot to write r. We should always... You know that to do a geometric sum, you got to have those two numbers. You got to know what a sub 1 is, and you got to know what r is. And you got to know what n is.
Yeah.
So I'm going to take that to the 8th and divide it by 1 minus 2/3. Again, I'll let you finish it. But notice how it's a little more cumbersome. If I've got 2/3 to the 8th minus 1, that's going to be a negative number, and then I'm going to have 2/3 minus 1 in the denominator. That's going to be a negative number. It's just when you do it the other way, you introduce negatives. And I spend half my career trying to talk people into using positives when they have a choice. In other words, when you're solving an equation, always solve it in a way that if you have a choice between using positive coefficients or negative ones, always choose the way that results in positive coefficients. It just eliminates a lot of opportunity for mistakes.
Okay.
All right. Let's see. What we got next here? We got find the number of terms given the sum. All right, this is a little tricky. Well, the best way to do this problem is to start with the formula for the sum. In other words, what is S sub n going to be? First of all, what kind of sequence is it? What kind of sequence? Is it arithmetic or geometric?
Arithmetic.
Okay. So what's the specific formula for this going to be if it's arithmetic?
It's n over 2, and then 25 plus n.
Plus a sub n. In other words, whatever that last term is, which they're not giving us, so if I remember right, what she did in her key was she wrote the sum there. I'm trying to solve for n. And what she did next was wrote and I assume she meant that that was a sub n. Yeah, and she ended up with a quadratic, if I remember right. Let's see, if we do the algebra here, what do we get? We get 6210 equals 25n plus s sub n times n. Now this is where I got a little confused in the first place. She doesn't really mean s sub n as in sum. She can't. So she must mean a sub n. Yeah, this is what confused me when I looked at her math there. A sub n times n. And she ended up with a giant quadratic. Ah. All right, I'm going to just, so that I don't hold things up here, I'm going to look at how she did this. I even had a hard time figuring it out when I was looking at it. All right, so if we look at her key, she's got 25 plus, and her a sub n, okay, now I get it, okay. Yeah, she does mean a sub n, and a sub n is equal to the first term plus our common difference here, if I pull it back up, our common difference is 10. Ooh, I don't like that. Something I didn't like here. 10 times n minus 1, right? There's our a sub n. So now I can finish solving this equation. I got 6210 equals 25 times n plus, well, a sub n is that. So if I write the n in front and then write whatever my a sub n equals, 25 plus 10 times n minus 1, now you'll notice what I end up with is a giant quadratic. In other words, if I distribute everything starting with that inside, so this becomes 25n plus n times 25 plus 10n minus 10, which becomes 15. And now we've got 25n plus 15n plus 10n squared equals 6210. All right, and now, like I said, we end up with a big quadratic. Here, let's start with the n squared term. We got 10n squared plus 40n minus 6210. Well, I can divide everything by 10. And now that's all equal to 0, because I moved the 6210 over. And now that's not an easily factored one, but it's going to give you a positive and a negative number. And if my memory serves me right, it's what? Oh, it's 27 and 23 are the two factors. Okay, so it's, ooh, notice that the 23's got to go there. The 27 with the plus sign got to go there, which makes the answer what?
It's 23 because it can't be negative.
Yeah, exactly. In other words, I end up with two answers, and I have to choose the positive one. What happened on the key? She crossed out one and put the other one. Oh, I see what she did. She factored it correctly, and then just crossed it out because you can't have the negative one. Okay. All right. Nicholas, I have an 8 o'clock that I'm going to have to go to, but
Okay.
hopefully this was helpful.
Yeah.
And at our next session, which is that tomorrow or Wednesday?
Tomorrow.
Tomorrow, we'll pick up from where we left off.
Okay.
Okay.
Yeah.
Let's see. When you signed in, I guess I can just send it to your mom's email address. Did you sign in with an email address?
Yeah, you signed in with your Gmail, right?
Okay.
My email, I think.
Okay. So I can go ahead. I'll send it to both you and your mom, the link where you can see the recording of this.
Okay.
And it won't be ready till tomorrow morning, probably after you've already headed off for school, but it's always ready the morning following your session.
Okay.
Okay?
Yeah.
All right. Have a good rest of your evening, and you can X out of this GoToMeeting program by just clicking on the X in the control box.
Okay. Thank you.
All right. You're welcome. Bye-bye.
Bye.
Okay.